In this video, we're running a mesh size accuracy test in Abaqus to answer a simple but important question. Does mesh size really matter? A lot of people assume that making the mesh finer will automatically improve simulation accuracy. But is that always true? To find out, we'll take the same Abaqus crash simulation from previous video and run it with 4 different mesh sizes: 4.5, 3, 2, and 1.5. We'll compare how velocity changes over the time for each mesh and see how mesh refinement actually affects the results. Then we'll go one step further. I'll show you how to plot the results, calculate the error based on the most refined mesh, and figure out which mesh size gives you the best balance between Abaqus simulation accuracy and computational efficiency. Are you ready? Let's get it started. Alright, we go to the file, open, and I have the folder here, crash element, double click, and this is opened. Now another thing I want to do is to go here, file, and set work directory. I want this to be here, so I basically copy this one and paste it here. So from now on, every job I create or any changes I create would be saved in this folder. So as you see, this is the simulation files from the previous video, which is the bullet impact. If you haven't watched the video, I put the link on top right here, or if you want to skip the simulations and get the files, just check the pinned comment down below. Right now I quickly explain what happened here. I created a sphere and a plate, and this one hits the plate. If we go here and check the job, you see here that the bullet hits the plate and passes through, just like this. Now we want to check what would happen if we reduce the mesh size. Okay, let's go to the mesh for this purpose. Now from here, query information. If you don't have it here, you can go to the tools and query, and from here you go to the mesh and done. Total number of nodes of 761 and 710. We need to write down this number somewhere, so I open an Excel file. Okay, here I write down the mesh size and mesh or element numbers and node numbers. Here the mesh size is 4.5. We want to do that for 3, 2, and 1.5. Now for 4.5, we want to write down this number of nodes is 761, and the number of elements is 710. Okay, now let's jump back to Abaqus. From here, if we go to the job and to the results, we go to the XY data, ODB field output, continue. Here it can be unique nodal, and this can be, we have the magnitude, and from here we can select one node, for instance this one here, and we plot this. And as you see here, we have velocity versus time. Now we want to have this plot here. We click on edit and we select the first one, hold shift, last one, and copy. Now here we have this one. Maybe we can write this for 4.5, and we're going to have more for other sizes. Alright, let's jump to Abaqus. Now you know the drill, and we're going to edit the mesh sizes. Here from global seed, I select everything and put this on 3 and delete meshes, and select everything and mesh them. In this case, number of nodes and elements would be different. So if I click on OK here, as you see, this is 1600 for the numbers of nodes. We want to write that down, and here we have 1500 for numbers of elements, and we will do that for others as well. Now let's go and run the job. Now I create another job. I name it crash element 3 and continue. Okay, and I want to just write input file, and here we have the input file here in this folder. So crash element 3 imp. I would like to open it with the notepad. Let's scroll down here, find the materials. Yeah, I come here and I want to write down this and copy this one and paste it here, save, and I close this one. Now I want to run another job, so create job. It is crash 3 or maybe crash size 3, and this one using input file. I want to put this one and OK and OK. Now we submit this job. For this one we have to do that all the time because the previous job was created with an IMP file in which the element size was 4.5, so which is different. We have to do that all the time to see how it goes. Alright, I would like to monitor the job here. Now we need to do that for others. Maybe I can create another model like this one. I can say model 2, and in model 2 I can go to the mesh, and here I select everything, put this value on 2 and delete mesh and create the mesh. Now again we have to go to the query, then mesh, and OK. Now as you see, the numbers of nodes and elements are higher, and we need to go and create another job. Then submit the job and copy this model 3, and in model 3 we want to go to the mesh, select everything, put this one on 1.5 and OK. Now mesh, select everything and done. Go to the query, mesh, and OK. These are the numbers of elements and nodes here. Now we have everything here. We go back here to the job. Now size 2 is completed. Let's go to the results here and put this one on this, and unique nodal, the same thing, add selection, and you select something like this and plot. Now here, edit, first one, go all the way down, hold shift and copy, and this is for 2, so I would like to write 2 here. Now let's do that for element size of 1. Yep, unfortunately the job is aborted here, but it's totally fine. We can make our decision here. So for 1.5 the elements were distorted here, as you see here, and it got aborted. Okay, I want to copy this one and put it here. Then we can do this with others, like here. Yeah, now this is 4.5 and we can plot them. So insert and plot. Now take a close look at the plots right here. This one is 4.5. Actually, if you take a look at the same time, something like here. For this one, the value is somewhere around 37,000, but when we reduced the mesh, it was 46,000. And when we reduced that to 2 millimeters, it was somewhere around like 55,000, which is big difference from 35,000 to 55,000 here. And for this one, it's like 59,000. If you want to see how much difference is between the two, here is like 59,000, and if you say roughly, this is 56,000. Here we have 59,000 minus 56,000, and we can have the parentheses here by 59,000, and we can say times 100, and we should put this sign of equivalent here. You see, this is 5%, so it means there is no need to go for 1.5 in the mesh, and the mesh size of 2 is totally fine because the error percentage is less than 16%. And as you see here, both of them are converging, and the results are no longer have difference of this big. So let's do that for others. Like if you say this one is 45,000, so here this one can be 56,000, and this one is 45,000, and here you see this is somewhere around 20% differences between the results. It means that you cannot select the mesh size of 3 or the mesh size of 4.5, but mesh size of 2 is totally fine because you can see the convergence. Another thing you can do is to copy and paste like these elements here, somewhere around here, and you can put the final value of each one here, like this one, this one, this one, and this one here. You can also plot them from insert. It's better to be like something like this, yeah. And as you see here, when we started with these numbers of elements like 710, this is the result. And as we go, you see there's a plateau. It means after a certain size of mesh, the results are being independent of the mesh size. We call this analysis mesh sensitivity or mesh independency analysis. Other thing you can do here is to go from viewport and create, this is for size 15, this is for size 2, and you can create a viewport for this one. You can go for size 3 and create another one for this, and you can create one from here, and you can open the other one, ODB crash element here, and you can create another viewport here. Then from viewport you can tile horizontally, for instance here, and this is a crash element, this is size 3, so this is repeated again, and now you close this one and you can tile them horizontally. You can do it one by one like this, or you can go from viewport and link viewports, so every change you make for each one of them happens for others as well. You can make this better by going to viewport annotation option, set all off, and you can only have the legend here, and you can modify the legend font or the size, like 8 is fine in order to see that better. Now this is linked and the time frame, and as you see here, this is the stress. We can have it for maybe V, which is the velocity, and this is here for this one, the magnitude is 3.7, and for the mesh size of 3 is 4.6. Here is 1.18, and this is 1.08. And that's it. If you enjoyed this video, smash the like button and subscribe to the channel to see more videos like this. Don't forget to click on the video on the screen before it ends. Stay tuned.